All right, thank you, Danny. Thank you, everyone, for attending. I know I'm between you and the after party, right? So we are sixth of the sessions here. And we basically wanted to start with a very simple question. You've heard so much about the database, the converged database, started with JSON, SQL, spatial, graph, right? So there's a lot of pieces in the database with machine learning as well. And then the question is, as you're building applications, how do you start to build something, what is a microservice? So I'm here, I'm Sanjay Goil. I have with me Paul Parkinson from Oracle. We have Guido and Rolando, who are Oracle aces. We're here to share, some of their experiences, ask them some questions, and hopefully kind of take you through a journey of answering this question, right? So if you're ready, we can get started. Very brief introduction about myself. I've been at Oracle for about close to 2.5 years. I do AQ messaging and microservices. I previously ran the Event Hub cloud service and briefly had come to Oracle to run the AI service, which translated into what is today the data science service. I have a lot of experience on the app side, did a startup in social media and TV ads, but mainly go back to building platforms, a big data platform at HP, at Autonomy, using things like unstructured data, Vertica, Hadoop, and other things. And at Sun and Intel, prior to that, building HPC, high performance computing systems and developer tools. So that's my background. Happy to be here. I'll go to Paul. Paul, could you please introduce yourself?
Yeah, my name's Paul Parkinson. I've been at Oracle for about 19 years now. And I've actually had pretty much the same role the whole time. I've been the dev lead in the transaction processing area for the mid-tier. So I've always worked very closely with the database tier for, innovations between the two. And most of those years were spent as dev lead for transactions and WebLogic. But everything, from SOA to all, transaction guard and application continuity and things like that with the database, I've been involved in those patterns and development. And so most recently that manifests in developing for the Helidon Microservices platform.
Oh, okay, so off on to Guido and Rolando. So we have two incredible voices of experience from the field. Guido, please go ahead.
Yeah, thanks, Sanjay. Hello, everybody. So my name is Guido. I'm from Switzerland. I'm working for a company called Trivaris. We're operating in the German-speaking area of Europe mostly. And I'm at Trivaris for more than 23 years. I started there as a PL SQL programmer. So I have quite a long time history working with Oracle databases. And then I did Java as well with Spring. I worked on the Oracle SOA platform, so I did quite a lot of work with service-oriented architectures. And the last couple of years, 8 years, I started working with big data and fast data. So stream processing, Kafka is kind of my hobbies. And with that, I also started working in the field of microservices.
Awesome.
And I'm a Groundbreaker ambassador, yeah, as an Oracle title or role.
We knew you had a lot of experience, so thanks for being here.
Thank you.
Rolando.
Yeah, thank you, Sanjay, and thank you, Paul. Thank you, Guido. Yes, I'm from Mexico. I am Rolando Carrasco. I work in a company here in Mexico by the name SPS. And throughout all my professional career, I've been working with integration technologies, mostly with Oracle, obviously. I started my career in Hewlett-Packard, and it was a very long time ago, around the year 2000. And then I moved to Oracle in 2002, and then started to work with integration technology within Oracle. And when Oracle people started around 2003 or so, I was pretty much involved in all the projects that were in the region in Latin America. And then I just continued doing Oracle people and SOA Suite and so on. And then in 2010, I started my own company and still doing integration things because that's my kind of my passion. And nowadays doing what I will say modern technologies, but it's just a way to describe them. But it's about containers and Kubernetes and microservices, if you will, and other things. But pretty much my career is oriented in the integration space.
Awesome, awesome. Glad you could make it. Thanks for being here. So let's get into the session, right? So we have about maybe 50 minutes to cover some of these things. So again, welcome to all of you. We are around the world. I'm in California. Paul is in Florida. Rolando, Mexico City. Guido is in Switzerland. I think the common language you speak is music, right? So let's, and of course, this is a party here. So we can all get into a party mood here. There's an after party here as well. So before we get there, let's get into our session here, right? So it's number 6. It's about building microservices, right? And the layout here is fairly simple. It will define what a microservice is, and then get into some recommendations from Guido and Rolando. I want to ask them the question around, how many people come to them saying, I'm already doing microservices, I want to do microservices, can I do microservices with the Oracle Converged platform, right? All that stuff, right? So again, maybe they'll share some of that experience from the people who come in and come to the Oracle Cloud and start, building applications right away as microservices, or the others who have been using Oracle SOA, Oracle WebLogic, and then come back and say, oh, we're kind of doing some service orientedness. How do I make it a little more agile and all that, right? So those kind of two views we'll get, from their presentation. I'll talk a little bit about Converged Database, the simplicity and others, but mainly have Paul talk about some of the live labs we have created, right? So there are some live labs where we pick up an application, right? Because all these things you saw in the previous sessions, there's SQL, there's JSON, there is spatial. Again, yes, each of them can help you build applications in those areas. But when you build a data-driven application, all these data types start to come in. And a good application, we thought, as an example, would be the mobile food delivery app, right? So things like, most of us use things like Uber Eats, DoorDash, and even in times of COVID, we'll probably use them more than others. But there's a lot of data, a lot of app, a lot of scale, the app platform, data platform around there. So I think a lot of that would resonate with you as Paul kind of covers that. And hopefully we can end up on time here so that you can go back to your quizzes, whatever we have planned after this. So our objective in this session is, answer this simple question, right? Can we make microservices simple? The answer to the fact that somebody's building a microservice or not is, I think, in the affirmative. If not, by the end of the session, you'll probably come to that conclusion. And then what about open interfaces? How do you build microservices with open interfaces? Simplifying, right? Again, the keyword here is simplification, simplifying the data platform, simplifying the code, simplifying the integration, right? And again, data-driven applications at scale. People have been doing this with various other architectures. So let's go and look at a definition, right? So I like this definition. This was probably done about 6-7 years back at Netflix. Adrian Cockcroft was there building the Netflix microservices platform. I'm sure most of you are familiar with that. Two key concepts here were loosely coupled and bounded contexts, right? So if you examine them, they give you a test in some ways, right? So if every service has to be updated at the same time, it's probably not loosely coupled, right? And the second is bounded context, right? If you know too much about the surrounding services, then you don't have a bounded context, right? There's some isolation involved in having a microservice, right? So again, using these as guardrails, we can come back and say, there are many questions, right? It's just not a tried and true science yet. It's about, having, thinking about the concepts of domain, concepts of coupling, concepts of APIs, concepts of event buses, all those things, right? So there's the messaging component that starts to get involved as well. And, I would be amiss if I said that the 12 factors were, the basic advice that you get, right? So for microservices, you can basically, go and see 12factor.net, and you'll see some of these concepts being covered in the app that Paul will walk us through. So today, a lot of people start with microservices, right? And there is this whole Lambda and Kappa architectures being thrown out there, right? So on the left side, you see producers of applications or producers of data, right? Applications, web service, order service, mobile IoT. They stream some of this data through a Kafka-like bus, right? There are databases. Then they, of course, do transactions, but then they also stream that stuff for, consumption down the line, right? So consumption from analytics, consumption from batch storage, right? So there's a aspect of batch, there's an aspect of streaming, and there's an aspect of consumption, ops dashboards, and other things, right? So you can clearly see it lends to some complexity in terms of having to have many technologies, having multiple data stores, leads to some copy contagion. You could really don't know how many copies you have. And, with security, with high availability, with backup recovery strategies, it kind of becomes complex and difficult to maintain. And of course, you then need to have skill sets. You need to have skill sets for each of these technologies, for Hadoop, for Kafka, for, Vertica, and all those things, right? So the whole move was from, a simplicity of a database and a data warehouse into the special purpose databases. And we kind of examine that, there is some truth to the aspect that, this provides you flexibility, but it also brings in some complexity. And our search is, is there a better way? Is there a simpler way? Can the Converged Database, all the technologies you heard being part of the Oracle Converged Database, simplify some of these flows, some of the outputs that a microservice really ought to do. So how do we start to think about microservices, right? If you think about microservices as an application platform, a data platform, right? And those two aspects, then the whole operating word here, simplicity of development, deployment, upgrades, maintenance, scale, cost effectiveness, agility, right? Again, that term loosely is architecture, right? So you can't, overstate the impact of architecture in these things. So let me ask a couple of questions here, right? So they seem to be simple questions, but they're not so simple as you start thinking about them, around thinking like, is the separate database needed per microservice? I mean, is that what a microservice is? Do I use REST APIs? Do each of these services expose REST API, or can we do something else like event sourcing, right? And how about expertise in the team and all that? So I think Guido has spent a lot of time thinking about these things. So I wanted to invite him to talk through some of the answers here. Guido?
Yes, thank you. So I have 2 slides for 10 minutes, so that's quite comfortable. And I would like to mainly talk on this slide here. And we'll start with your first question. So is a database per microservice really needed? And I think you basically have to define what you mean by database. And I think we should not talk about a database by microservice. What I really think is important is that a microservice owns its data, or the microservice team owns the data. So it should be only one microservice owning some data. And it doesn't matter if this data is in a completely different instance, or if it's in one instance and you might have some separation based on schema, which we already have in Oracle databases and we use for a long time, or if it's something else. And of course, you have the freedom as a microservice team to choose the best tools for your job. So that starts with the programming language, but that also, or that ends with the database basically. So it's the term polyglot programming and polyglot persistence basically means that a developer nowadays has to work probably with different languages, and he also might have to work with different databases. I think that's needed if you want to optimize for a special purpose, and if you have kind of a big data or fast data scenario with lots of data, then you might need a very specific special database. But nowadays, more and more, we have also multi-model databases, and the converged database is basically, in my point of view, just another term for that. And I think it's always good to think about reducing complexity, and reducing complexity also means reducing the amount of tools and products you basically use. So you should try to reduce to the absolute minimum. So saying that, if I can only have one database and share that database with other developers or other teams, but still have my own data and owning my data and have the security and the safety that I'm the only one who's able to touch that data, then I think it's fine to be in one database. If the database is just the critical piece in terms of scalability, then you might want to rethink and have your own instance. But it shouldn't be just like a rule, I need my instance, otherwise I'm not doing microservices. And I think it's also important to have kind of two perspectives. In a microservice architecture, we often talk about the microarchitecture, sorry. That's the architecture inside your microservice. So you as a team, you decide on the inside architecture of your microservice. So that starts with which program language you want to use, how your data model looks like, what kind of database technology you use underneath. And then you have the macro architecture. And if you compare these two, the micro architecture is much more simple than the macro architecture. The macro architecture is where it gets more complex, where we get more people or more player on the field. Because now in the macro architecture, this is basically the links between your microservices. So how do these microservices communicate with each other? So all the microservice, all the players are now in the field, and you have to discuss and argue about a lot of things. And it basically starts where, how do you communicate? And I'm saying here, communication between services is complex. That starts with the fact that you're in a distributed world now. You want the decoupling. I completely agree that you need a tightly scoped boundary around your microservice, and you have to be decoupled. And decoupled means you probably start just having your own runtime environment. But that itself doesn't mean that you're decoupled, because the decoupling also means you probably want to communicate, and communication again brings some coupling. And you have to think about what you use in terms of communication, what kind of semantics you use, or what technology you use. And you have basically three different ways, three different mechanisms how you can interact. And we are very well, we know very well command and query, because that's how we grew up in IT. So command is usually synchronous. Command is a command-like way of communicating, which usually means I'm giving a command to another microservice. And on the picture on the right, where you see order microservice, shipment microservice, these are some typical bounded contexts you often find. And of course, the order microservice, if he thinks it's now time to ship the product, he can give basically an order, a command to the shipment microservice, ship that product or ship that order. And so this is a command style. If you work in a command style, and we're just used to doing that in the service-oriented architecture, we mostly had commands. Then you also have to take care about the answers. So or about the errors you might get into. So if this shipment microservice is not reachable, what do? You get an error, and you have to handle that error. The other mechanism is query. And query is not giving a command in a way, but it's still synchronous in a way that you want to ask for something. So for example, a UI application on the left, the shop web application, of course, does a lot of query, because the shop needs to know from the customer microservice the last profile information for a customer when he logs in. So this is a query. You want to ask for something and you get something back. And in that case, you can't avoid doing it synchronous, because you basically ask for something and you need it, otherwise you cannot continue. So if you do in a microservice world more monolithic UIs, then you probably have lots of such calls. But coming back to the order, giving a command or an order or a command message to the shipment microservice to ship an order, we could maybe think to do that differently, because I'm not really interested as an order microservice to get an answer from the shipment. If you really think about bounded context, your responsibility as an order microservice is just to handle that order. And at some point you decide or you define that this order is validated. And this information, an order is validated, you can also send that out as an event. And if you do that, if you send it out as an event, and you'll see on the right side, the event hub, that is a new infrastructure which comes into the picture. And so you need an infrastructure where you can send out the event. And now in that way, you have no longer a coupling to the shipment microservice. Of course, you have a coupling to the event hub, but the event hub should be really an infrastructure service similar to the network. And anybody else, this is now publish subscribe, anybody who is interested in that order has been validated event can subscribe and can take that event. So that would be the shipment microservice, and actually do what is needed as soon as an order is validated or is ready to be processed, or whatever you call it. And also the name of what you do will change. In the command way, you basically formulate it as a command. So do something. In the event-oriented way, you should formulate your event as the information about the event. So order has been validated, or order is validated, and you don't specify in the name of the event what should be done, what should be done based on that event. The one who is subscribing on the event can decide that, and is now handling that part of the business, and he's now responsible for getting that event and do his job. And the order microservice doesn't have to care about that. His responsibility is done. Of course, in a broader sense, of course, he cares about the whole business, but he doesn't have that responsibility. And I think that's a very important aspect. And for those of you who are working in the SOA, service-oriented world, on the SOA platform, we had a thing called Event Delivery Network. This was that was the same idea, but this Event Delivery Network had some troubles, some limitations on scalability, and that's why it wasn't really usable in real life. And nowadays we have event hubs such as Kafka and other products, and these are just kind of the event delivery network on steroids. So you can really deal with a lot of events, and it's safe to use that. It's reliable, and by that it's a very good working infrastructure. And so other important concept, I think, is the term smart endpoints and dumb pipes. And maybe you can go to the next slide, please. So here I would like to visualize what that means. And I think it's really important. And in the previous slide I had the question, is microservices just SOA done right? And in a way, I think it is SOA done right, because we will hear from Rolando later about the service-oriented principles. And we also find these service-oriented principles when we do microservices. What I really think what is different compared to the SOA world, where we had the service bus in the middle, is that we should no longer think about smart pipes. The pipes are dumb. And we have the logic we did in the past in the pipes, we have that on the endpoints. And this is more organizational aspect, not really a technical aspect. When we talk between microservices, we will still end up in a situation that service 1 doesn't understand service 4. And in the SOA world with ESBs, we basically told everybody there's magic in the middle, and you can talk with, or you can come with whatever format you have, and we magically transform it in another format the service 4 understands. And by that, we had a lot of responsibility in the middle. And we organize that into integration teams, or one integration team who is doing that middle part. And that integration team had to know a lot of things of business aspects, because transforming a message into a new format is not just technical. It's also a lot of business know-how is needed. And now in the microservice world, we'll still have that transformation, but the transformation will be inside the bounded context of a microservice. And I don't mean that in a technical sense, but I mean it in an organizational, in a responsibility sense. So service one is responsible to change the message before he sends it out. Or if service 4 wants to accept the message and it doesn't fit to his needs, he has to do that work. It doesn't mean that it's in the same language, in the same infrastructure as service 1 is using. You can still use some integration specific frameworks or infrastructure, but it's your responsibility to use it to do the work. And you don't have somebody else you can point the finger to and tell these people have not done their work. They're always too slow, and that's why I'm not able to be faster. I think these finger pointing aspects, that was more an organizational issue and less a technical issue. So if you maybe can go back again, I will wrap up by just saying, I think this concept of using both commands, I'm not saying that commands are a thing of the past. You will still find a situation where command is good, query you definitely need, but I think adding an event bus to the picture and communicating between microservices through events makes you much more decoupled. And I think that's an architectural concept. It doesn't mean that you need the products I already told you. It doesn't mean that you need Kafka for it. It doesn't mean that you need tons of NoSQL databases for it and all different frameworks, starting from Spring to .NET to Python. You can also keep it much more simple. And I think that's where the whole converged database goes to. And if I have less tools, I think it's always good. But I think if you have less tools, it doesn't mean that you should start simplifying the architecture and go back to the old world. You can still use a very decoupled way. And by that, you have freedom to maybe even if you start small inside one database, you also have the freedom to move things out if you find out that you have a need for it. So
awesome.
thank you. That was what I wanted to talk about. Yeah.
Awesome, awesome, Guido. So I think you kind of toyed with the loosely coupling of the services in this diagram, right? And also looking at bounded context so that you don't taking dependencies between services. Right? So those were kind of the two main points. Awesome. Thank you. Thank you for that, Guido. And of course, you know, there are folks who are thinking about SOA, right? And is it a similar paradigm as microservices? Are we already doing some microservices? Or, you know, is it micro or macro, right? Because there was always this thing about, you know, just, is it one individual doing its own bounded context, or is it a team doing a bounded context, right? So there is, you know, some of that stuff. Reason to move from SOA to microservices. We see customers. I know Rolando sees customers, Guido sees customers, and then some suggestions to get started on that journey, right? So Rolando, take it away.
All right, thank you, Sanjay. Thank you, Guido. So just moving forward from what Guido was saying, and I'm pretty much very well aligned to what Guido said. I've been always a follower of Guido, and so I pretty much aligned to him. So what I would like to start with is, and actually Guido mentioned it, so there are many technology aspects around it. That's true. There is a lot of technology nowadays. That's true. I strongly believe that we are living in this era where we have at our disposal as many or as much technology as we like, and we can pretty much build software with many alternatives. So I think that is one of the reasons why sometimes it is difficult to get into this, and it is difficult to understand this type of architecture. So that's my point. But in the other hand, if we just get back a little bit and we just kind of hold our horses, if you will, that's the way to say it. SOA is a discipline, all right? Okay, the SOA is a discipline and it is an architecture. And ultimately, what we are trying to do is building software. But nowadays, more than ever, we are building distributed software, distributed pieces of software, right? And then is where these type of concepts come into the picture and really help us to build a strong distributed system. But as in any other thing in our lives, if we do it with discipline, then we are going to have a good result, all right? And that discipline comes throughout a set of patterns, a set of services design principles. And if we follow them, then we can really go into the right path into this architecture. In a specific microservices, it is nothing more than, or in my opinion, nothing more than a subset of design principles of what the service-oriented architecture is. It is a subset of those principles. We are talking about discipline, okay? And those design principles can be identified as with abstraction, for example, loosely coupling, which has been mentioned throughout this conversation, autonomy, and it is pretty much what Guido was mentioning during his. We need a lot of autonomy with our pieces of software because this is a distributed environment and we do have a specific responsibility in this system. Composability, because we have different pieces and those different pieces needs to be composed in if it is through commands and if it is through a old school orchestration, if it is through events or whatever that we would like to compose them, we need to compose them. And we need to maintain a standardized contract. So, okay, so every time we build a service, it is a very good idea to standardize its contract. So as the title of this slide says, SOA is a discipline. It is not a technology. And if you are really thinking on moving from your current architecture in terms of technology, because you find your technology needs to be upgraded, if you will, or you just are trying to improve it, then just take a minute and think about your principles and how you've been building all those services so far. And if you are really building those services, then you can move to a different architecture, obviously, all right? So again, if you are really designing services, then you are in a very good position to move forward. So I think we can move to the next slide, Sanjay, please. But what about the Oracle SOA suite? Because as I mentioned, when I was introducing myself in the beginning of the conversation, I've been pretty much doing SOA throughout all my professional career because I started, as I said, in 2001 to work with technology. And since the very beginning, I've been involved with integration technology. So when the Oracle SOA suite came into the picture, I just like, I don't know how to say it, but it was like love at the first sight, if you will, and really pretty much get in love with the platform and started to use it. And I was very into the community and sharing my thoughts and blogging and videos and conferences and so on. So I really like the technology is part of my life, the SOA suite. But it is true that it is a product that it is not a new product. It is not built on top of a modern architecture. That's true. It is not built on top of a new technology because it is pretty much based on an application server. So everything what we've been talking until now in terms of distributed systems and so on, nowadays, probably if you deploy them on top of an application server, probably you will have some concerns about it and some limitations on that. I repeat it, maybe some limitations on top of that. It's not that you cannot continue doing that. You do have some limitations on top of that type of architectures. And one of those things, just to give an example, is what Guido was mentioning about this event functionality that the SOA suite had. And that is just one example of that, all right? And sometimes people use it as a services platform because it is a services platform. It is a way to build services and deploy and manage and operate services. And also people and customers use the platform as an integration platform, all right? And in my opinion, that kind of has different dynamics. If you're really doing services, then it has kind of different dynamics for an integration or for a pure integration need, all right? But again, if you are going into this direction where some of your services, which are running currently on top of Oracle SOA suite, needs to be moved into a microservices architecture, and I'm gonna give you some examples of that, of why you will be doing that, Then if you are really doing this discipline of SOA again, then probably the architecture can be deployed in a different way, in a different technology. And one of those technologies can be, for example, the Oracle Kubernetes engine, all right? So I think we can move to the next slide. So what would be the reasons of doing this type of change? Okay, so every time we are talking about this, there must be a strong reason to do this, all right? It is not that just your manager, your boss is saying to you, hey, don't use SOA Suite anymore, now use microservices. If for some reason your manager says that, then just, you can really have a good discussion with him, because it is just not a matter of changing your technology. That technology has been there for a while. It is actually running properly now. It does have some limitation, that's true, but those are not the right things just to say, okay, I'm going to move away from that. There must be very strong business drivers around it, okay? And nowadays we do have those type of business drivers, and even with this pandemia, or I don't know how to say it in English, but all this coronavirus thing, it is probably going to make the organizations to create new ways to do their businesses, and a new way to get interaction with their customers. And probably these organizations are going to start to receive a different set of transactions from places or from different channels that they don't have now. And then there is a business driver, because we do want to restart the economy in such a way, and we do need a way to receive all these set of transactions. So first of all, and that is why I put it in the first place, there must be some business drivers and needs to do this, all right? You must be thinking about it. And obviously we are technical people, and pretty much we like to program and develop software and so on. But at the same time, we need to understand those needs, all right? For example, different consumers, generating different dynamics of your services, and you need to respond accordingly with agility, all right? So you have a web application, you have a mobile application, you have a chatbot interface, so you have B2B interactions with other organizations, and you would like to maybe use a set of services, and those set of services, whatever service they represent to those consumers, and you want to differentiate all that, then probably this is a good way to do it. If you want to isolate your services because you want to scale them in a different fashion, or you want to differentiate which is the consumer and then scale those services from that transaction that those consumers are generating for you, then probably you want to isolate them. Or you need some auto-scaling features or isolation or performance or containerization, then probably these are good reasons for you, in technology reasons, in order to move into that direction. But the first thing, as I mentioned, is the business drivers, all right? Those are the ones that needs really to push you to move and then represent your software architecture in a different way. Okay, so let's move into the last slide
So Rolando, can you just maybe accelerate a little bit and talk about maybe your top 3 or 4 of these? I want to give Paul some time as well. No, it's about 9:40 or so right now.
Oh yeah, absolutely. Let me just move a little bit faster, and then yes, I'm not going to go through all of them. Yeah, you're correct.
Thank you.
So these are set of suggestions, because I do have some SOA customers, and I've been working with them because they do have business needs, and they do have business needs that they can translate into a different architecture. And then I can give you these suggestions. Okay, so the first thing is do this in a progressive way. Okay, this needs to be very clear. You don't need just to move the whole piece of the SOA suite, which is pretty large, and you can move that into this architecture in a big bang plan. Just don't do that. Just try to identify a set of services. If you have OSB services, then probably the logic that is within the pipeline can be a good candidate for that. And obviously you need to, with these design patterns, to design it in the best way now in the microservices architecture. And other things that I can also share with you is, if you are using JMS on top of WebLogic as a messaging communication approach for your services, you can turn that into a different messaging system. For example, what Oracle has in the cloud for queues. Or for example, if you have this set of cross-cutting functionality, for example, within Web Services Manager, authentication, authorization, or if you have these model or data transformation needs, you can just include them in sidecars, for example, for microservices. And if the architecture is looking or needing this, probably you will get into a service mesh type of thing. So we can go through this in a different session if you can just talk about these 7 suggestions or even more suggestions about how to move from SOA suite to this microservices architecture, and we can talk for a while for this. But just to give time for Paul and the rest of the session, I think you can just maybe just do a screenshot of this and follow these suggestions, all right? So thank you, Sanjay, thank you.
All right, thank you, Rolando. Yeah, so sorry to rush you through a little bit. But again, I think as we see between what Guido has said and Paul and Rolando, you followed up, there are paths for people who are doing SOA into adding microservices. Now, we run into a lot of customers who ask us, we are doing SOA today, how does microservices become relevant to us, right? So I think, you have laid out quite a few thoughts and some suggestions that, we can follow up with folks. So again, I want to give Paul most of the time, but I want to set it up. We have talked about a lot of these technologies in the Converged Database, but there is more, right? There is in-memory, there is some cloud integration, there is multi-tenant, there is hyperscale, there's blockchain, and of course there are events in the database now, right? So again, all of these come together in terms of building an application, which is a microservice. And what we talk about this convergent simplicity is this, you saw the diagram earlier on with many, many technologies, but here you start seeing a converged database with built-in event queues, right? So we have taken AQ and have scaled that further and, made it an events hub in some ways with managed services, cloud scale, all that stuff, right? So it kind of simplifies with open interfaces, easy app, building blocks. So, and of course, Paul's example will show you some of these things. This is what the converged database architecture looks like. People, of course, want to deploy containers and Kubernetes at the app layer, and then, PDBs with various data types, right? So there's JSON data type, there is relational, there's spatial, and then, the example that we're talking about, the mobile food delivery, we'll talk about these things. This is the example, right? So this is again, example which illustrates that at the core, there is some transactions happening, right? There's an order service, there's an inventory service, there is a delivery service, right? So all these services, and of course, around the edges of it, you start seeing there's a lot of AI, ML, there's data-driven aspects that, somebody wants to build, right? So again, it's a rich set of things that illustrates the aspects of building microservices on the Converged Database, right? So we have labs, and Paul will kind of talk with some of the setup of these labs, right? So lab 1 sets up the infrastructure, lab 2 builds on it, on the code. How do you do that registry, OCR registry? Lab 3, open service broker, multi-tenant, Helidon, the event queues. Lab 4, Lab 5, app, data platform, and Lab 6 is around polyglot coding, right? So this set of labs will be available. So Paul, I wanted to hand it over to you. So do you want to share so that you can walk us through the example?
Yep. Yeah. So I do have a lot to cover. So I do want to show as many things as possible. So I'll move at a pretty good pace, but try not to ramble at the same time. And I see, this lab, this is the page where the lab is, and we're going to be continuously building on this. So we have a long list of things that we've done that we're adding and things that we're going to add in the future. And it focuses on, the data aspects of microservices, which pretty much everyone will agree is probably the most difficult aspect as far as moving to microservices. And I saw some great chat questions coming in as far as the data integrity and things like that. And that's exactly right. That's really gets to the heart of it. So I'm going to show a bunch of things that, facilitate it. And then we're going to talk about some of those data integrity aspects. But of course, we don't have so much time to get into it, but we're going to touch on that. And then we can, go and delve into it deeper afterwards. So this is the lab, as I say. These first few steps are setting up the infrastructure. So the lab allows you to build this architecture that you see in the middle here, and we're actually adding to this as well. But I want to point out the fact that one all of this can be done for free, which is nice. You can do this with the OCI free tier. Helidon is free. And it's built in a modular way. So you don't have to build this whole thing. You can pick the areas that you're interested in and go from there. So after you've completed these first few labs for setup, what you end up with is this portion of that architecture. And so within an hour or so, you have all these OCI services, an ATP database, an OKE cluster. You've set up a queue, propagation between the queues of the PDBs, and you have microservices deployed. So, very easy to set things up. And so this is the sort of a DoorDash, VeggieDash type app that we're using for the use case. And one of the things this app shows is the Converged Database features as far as data types. And so the basic flow of the core part of the app is a customer placing an order, and then that order being checked in inventory to see if that order item exists, or if inventory for that item exists. And if it does, then the order is successful. If not, it fails. And then if it's successful, we can see the delivery information. So the order is inserted into the database in the JSON format. The inventory is in a relational format, and the delivery information is in spatial format, all within the same PDBs. So it's a nice showing off the converged database aspects. So we'll go into the app, but I want to quickly show kind of the front door to everything, which is connecting your OKE cluster, your microservice environment here, to the database. So I'm just going to go through that flow very quickly. I'm going to go into the source. I'm going to go back and forth between the source to show you some concepts. So in Kubernetes, or in CNCF, the Cloud Native Computing Foundation, which is kind of where a lot of these standards for microservices lie, there's an open service broker standard. And Oracle has an open service broker implementation. And basically, at the end of the day, what that does is it gives you the connection information you need for any cloud service. And in this case, we're using the ATP database service. And puts that information, puts that binding information into a secret in Kubernetes. So one of the resources in Kubernetes is a secret. And so this binding has all your TNS names, your wallet, et cetera, that you need to connect. So you provide the service broker with your username, the database ID, and it in return puts this secret, this binding, into your Kubernetes environment. Then you have another resource in Kubernetes called a deployment. And this is a description of your microservices, basically. And so in this case, we see that we have this order Helidon microservice. And we're taking that secret from the service broker and mounting it in this container. And then we're taking that information and setting the environment for our microservice. So we use the OSB to get the secret for the connection information. We put that secret into our container, and then our container took that and provided the environment for our microservice. So it's a very easy flow to then have connectivity from your microservice to your ATP database. And like I say, it takes minutes to do this. So in this particular case, the microservices are Helidon microservices. So Helidon is a framework for developing microservices. And we decided to provide two different versions. And they're more or less the biggest difference is the style of programming that you're using. So Helidon SE is a more functional reactive style. It's just a kind of a pure reactive approach. And then Helidon MP is an implementation of the microprofile standard. So if you are familiar with Java Enterprise Edition, microprofile is essentially that for the microservices world. And so this is, a very natural migration path for people on an application server to come over to the microservices world using, full CDI support, a lot of the same annotations that you used when you were running on WebLogic or whatever. So there's these two flavors, and the microservices we have here are implemented in those two different versions. So in MicroProfile, there is a standard, and you'll see here when I brought this environment in, I used this naming convention. And so I got the binding information that was provided, in the secret by the service broker, as I mentioned. And I'm going to create a data source with the name order PDB and then set these values on it. So that's in our environment for the microservice. The MicroProfile standard defines those values. And from this properties file, it creates that data source pointing to the database and injects it into our microservice. So our microservice, a lot of these microservice technologies are about bringing out these, common concerns, these cross-cutting concerns. So your microservice is very clean. And so as far as connecting to that ATP service, this is all you had in your microservice code, and then you can access it. And it's nicely decoupled as well. You could change what that database is. At all levels, we're kind of decoupled. You can move PDBs around. You can move what PDB you're pointing to around in this deployment, and you still have this nice decoupled reference. So I just wanted to go through that a little bit to show the connectivity aspect, because obviously that's the first step. So now let's go into the actual demo app that you build with the lab. And these tasks are the setup. We'll be focusing on task 9. And this is the order inventory scenario that I described. And so what we'll do is we'll check the inventory for a given item, cucumbers, and we see that inventory is now 0. And so we'll just make sure that there are no orders around so we don't get collisions. And then we'll place that order knowing that there is not enough inventory for it. And so we see the order status is pending, so then we go and check the order, and we see it failed because the inventory did not exist, okay? And then, of course, if we go ahead and add inventory, just clear the order so we can use the same order ID, place the order, and then check, we see the order is successful because the inventory exists. We also note this, and I'll bring this up again in just a minute, that we see the inventory location and a suggestive sale item. So now let me take you into the tracing a bit to show you exactly what just happened with this. And in this, we're going to demonstrate the event-driven communication, which Guido went into a lot of this, so that's great. I don't have to re-explain it. And the concept of the Saga. So this is Kiali, and this was another question I noticed in chat. And like I say, we can certainly elaborate on answers afterwards in Slack, et cetera. But tracing, setting up the flow of your microservices. So you can set them up with a number of different tools. I won't go into that, but there are a lot of great microservice observability tools, and Kiali is one of them. It works with a service mesh architecture, and I won't go into that, but it provides a call graph, a visual call graph representation of your microservices. And so, of course, you're spreading these microservices across the network. You really, these tools are very valuable. And so what you're seeing here is the front end placing an order. These are our interactions. This was just to set up the database initially. Our interactions from the front end are only with the order and the supplier. We don't directly talk to inventory, and order does not directly talk to inventory, and supplier does not directly talk with inventory. And that's because we have this event-based communication. So what's happening here is the order is being inserted into the database, and a message about order placed, as Guido was saying, the verbiage of the event is order placed. And now one of the most important aspects of one of the huge advantages of AQ that is very unique out there is the fact that you can insert that order and send an event in the same transaction. So no one else has this, and this is very valuable in the microservices world because you don't have message loss. Your microservices have an exactly once message delivery guarantee. So they always say microservices, you have to program them to be idempotent. Well, that's easier said than done. And with AQ, you don't have to do that because you'll get the exact once message guarantee. So I'm gonna have to really scoot through this because we're running low on time, but the main point here is that the communication is decoupled because the order is being placed into the database and the message broker here, and then inventory is picking it up. and communicating back the fact that there is or isn't inventory, which the order service is then picking up that event. And it knows if the inventory does not exist, it's a failed order. And if it does, it's successful. And now that's referred to as a Saga, because in microservice architecture, you're spreading this network apart. You have these potential issues with the network, potential long-running activities coordinated between different microservices. And so you can't use traditional protocols such as two-phase commit and XA without running into issues as far as scaling limitations or straight up errors if you're holding locks for too long. And so you have to use a newer, which actually Saga is a protocol that's been around for decades, protocols to handle this. And what goes on with a Saga is each participant in a Saga defines the action it's going to create, but also a compensating action. And so for the order case, the action was a successful order, and the compensation is to mark the order as failed. So I'll go into that a little bit more after the show some of these other concepts, but that's the basics of the Saga. And then back to the fact that we're seeing the inventory location and a suggestive sale item when we do a show order. That is showing a concept called CQRS, which is, and again, Guido went into this bit, the separation of the command and the query. The command was an insert into the database, but the query was actually a result of events that came back. We did not do, when the show order call was made on the order service, order did not go and call inventory service or suggestive sale service or anything like that. It was decoupled because it received that information from events from the inventory service. And so that's the concept of CQRS. So very quickly, Heladon can advertise metrics. It can advertise its health, whether it's live or it's both live and ready. And by doing so, it works with OKE health probes such that, and I'll just show this very quickly. If you have a health probe in OKE in Kubernetes, it will go around and check your microservice at a certain amount of time. And if that microservice advertises the fact that it's not healthy, then Kubernetes will go ahead and restart it. And then just one quick concept, when we were talking about this tracing, you can also drill down on that tracing into this open tracing architecture. I'm trying to show these important aspects of microservices. When you're spreading these things all over the place, you need to see what's going on. So, and somebody did kind of ask a question on that, so that's good. So you can drill down into this open tracing. And in this case, we actually see web, and this is to Rolando's point, we have this mixed architecture where in this case, we have WebLogic calling into Heladon, calling into the database. And then we can drill down on those traces to see what the Saga ID and the order ID, et cetera, was. So that was a bit rushed, but I'll go ahead and hand it back to you, Sanjay.
Sure, thank you. We talked about the platform. So let me skip this one. So we talked about Saga, and we can continue the conversation on the Slack channel. Right, so you can build a microservice based on the labs anywhere you are. So you can touch the Oracle cloud infrastructure with the always free instance, and you can also collaborate with us. We have some ideas around using spatial data. So if you look at the application is fairly rich in terms of delivery and using spatial data there, using graph data in terms of social graph recommendations. So again, things you can add to these labs that you can put on your own GitHub, which we can link to. Again, there are various ideas here. This deck will be available. You guys can talk about it, or maybe come back to us on Slack channels, and we can discuss these things. One final word. A lot of people think about app and data separately, right? And what happens is, you spend a lot more time in the app, but not as much on the data platform. We believe in our experiences that we've seen from customers is building these things together. Think about the data platform as much as you think about the app platform and its scale as well, and kind of do them together. So that brings us to the top of the hour, and hopefully we'll continue this conversation on the Slack channels that Tammy has set up. So back to you, Tammy.
Hi guys, thank you so much for joining everybody. Fantastic session today. I cannot tell you how much we appreciate everybody joining us today. And thank you so much for everybody to join us again.